The next two lessons are great previews for things that you might talk about if you move on to trig and especially calculus. In calculus, we will calculate ways to determine the intervals of increasing, decreasing, or constant behavior. Here, we're just going to look at a picture and determine where is it going up, where is it going down, or where is it staying the same. So let's take a look at an example together. Again, all I'm doing is looking for everywhere first where my function is increasing. So it seems to be increasing from here to here, and it seems to be increasing from here to here. So two parts. This part, the left-hand side, is negative infinity because there's an arrow. I covered it up with all my scratches, but there's an arrow. And it goes up to this point, which is at -2. And so in addition to that, I've got the point from +2 up to forever, positive infinity. So increasing would be from negative infinity to -2, union from 2 to infinity. From constant behavior, it seems that the constant behavior would be, let's use green. Oops, I guess I skipped over decreasing. We'll come back to decreasing. Constant behavior happens right here. Constant being nothing is changing. And that is happening from -2 to 0. And notice I use the close brackets on that because that seems to be included from -2 to 0. Those values are included. The decreasing, running out of colors, how about blue? Happens from right here to right here, which goes from 0 to 2. And again, those would be open brackets. I've already used the exact point of -2 and 0 in my constant behavior. So that's how I would divide up this domain for increasing, decreasing, and constant. You give it a shot as well. Be careful on this one. It's not as straightforward as it looks. Once you're done, press play to see how you did. So if I'm looking at this, I can see that there is no area in which this is increasing. The graph is never going up from left to right. So no increasing. Same thing, no constant behavior because it never just levels out. So you might be tricked into thinking that I can just say negative infinity to positive infinity, it's decreasing everywhere. But that would be misleading because we have a couple of points here, right here, and right here, where it's really not decreasing. It's not really constant. There's a change happening, and so we're not going to include that in the decreasing behavior. So I'm going to say that this is negative infinity. I'm talking about on my x-axis, of course, and that this is positive infinity on my x-axis. So I would include negative infinity up to -3, where that first green point is, union from -3 to +2, where that second green point is, union from 2 on to forever.